We all gazed up at the night sky and felt a sense of wonder looking at the stars. But tonight, we turn our attention to a celestial object that shines just as bright: Jupiter, the largest planet in our solar system. Imagine a world so colossal, it could swallow 1,300 Earths. Jupiter is a gas giant, a swirling vortex of colors and storms, a place where the laws of physics seem to be written in a language we're only beginning to understand. It's a planet of extremes, with a magnetic field so powerful it could disable a spacecraft in a storm that's been raging for centuries. In this epic journey, we'll explore 10 mind-blowing facts about Jupiter that will leave you in awe. We'll delve into its turbulent atmosphere, its colossal storms, and its intriguing moons. We'll uncover the mysteries of its core and marvel at its dazzling auroras. So buckle up, space explorers, as we embark on a cosmic adventure to the king of our solar system, Jupiter. Prepare to have your mind blown wide open. Out here in the cosmic neighborhood, things can get a little dicey. Asteroids and comets, remnants from the early solar system, hurtle through space like cosmic bullets. And you know who's standing guard, protecting us from these celestial projectiles? That's right, Jupiter. Jupiter, with its immense gravitational pull, acts like a cosmic vacuum cleaner, drawing in these potentially hazardous objects and either flinging them out of the solar system entirely or absorbing the impact itself. It's like having a really big brother looking out for you. Remember Comet Shoemaker Levy 9 back in 1994? That comet, fragmented by Jupiter's gravity, slammed into the gas giant with the force of millions of atomic bombs. The impact scars were visible for months. Now imagine if that comet had been on a collision course with Earth. Not a pretty picture, right? So the next time you look up at Jupiter, remember to give a little nod of thanks to this celestial guardian. It's out there, working tirelessly to keep our little corner of the cosmos safe. Now let's talk about one of Jupiter's most iconic features, the Great Red Spot. This isn't just any storm, it's a swirling vortex of hurricane-force winds that's been raging for over 400 years. That's right, this storm is older than the invention of the telescope. Imagine the stories it could tell. This crimson tempest is so large that you could fit 3 Earths inside it comfortably. And it's not just its size that's impressive. Winds within the Great Red Spot whip around at speeds exceeding 400 miles per hour, faster than any hurricane ever recorded on Earth. Scientists have been studying the Great Red Spot for centuries, trying to unravel its secrets. Why has it lasted so long? What fuels its incredible energy? While we've learned a lot, this enigmatic storm continues to hold many mysteries. So you think your days are short? Consider Jupiter, the behemoth of our solar system. This gas giant spins at an astonishing rate, completing a full rotation in under 10 hours. That's right, folks, a Jovian day is just shy of 10 Earth hours. Now imagine trying to set your cosmic alarm clock on a planet where the sun rises and sets in the blink of an eye. Your morning coffee break would be interrupted by nightfall, and you'd be hard-pressed to fit in a full workday before the stars came out. This rapid rotation isn't just a cosmic quirk. It has profound effects on Jupiter's appearance and atmospheric dynamics. The centrifugal force generated by this spin flattens the planet at its poles, giving it a slightly squished shape, kind of like a cosmic basketball someone sat on. And if you're a fan of extreme weather, Jupiter won't disappoint. This breakneck spin whips up winds to unimaginable speeds, contributing to the planet's iconic bands of swirling clouds and colossal storms. Now let's talk about family. Jupiter takes the concept of having a lot of siblings to a whole new level. This gas giant boasts a staggering number of moons, a whopping 95 that we know of, and counting. That's more than any other planet in our solar system. It's like Jupiter threw a cosmic party and every passing space rock RSVP'd yes. These moons come in all shapes and sizes, from tiny asteroid-sized objects to behemoths larger than our own moon. Each one a fascinating world unto itself with its own unique story to tell. But among this celestial entourage, 4 moons stand out as true celebrities: Io, Europa, Ganymede and Callisto, the Galilean moons named after their discoverer, the one and only Galileo Galilei, who first observed them in the 17th century. These moons are so large they're easily visible with even a modest telescope, and trust me, they're a sight to behold. We all know Jupiter is big, bold and beautiful, but what about its magnetic field? Now, magnetic fields might seem invisible, intangible things, but trust me, they're a big deal in the cosmic scheme of things, and when it comes to magnetic fields, Jupiter doesn't disappoint. In fact, it boasts the strongest magnetic field of any planet in our solar system, a whopping 14 times stronger than Earth's. Now that's what I call magnetic charisma. This magnetic field is so vast it extends millions of miles into space, forming a protective bubble around Jupiter known as the magnetosphere. Think of it like a giant force field deflecting harmful radiation from the Sun and shielding Jupiter and its moons from the full brunt of the solar wind. But this magnetic shield isn't just a passive barrier. It's a dynamic and ever-changing region of space, filled with charged particles trapped and energized by Jupiter's powerful magnetic field. Jupiter, a planet so massive it's practically in a category of its own. It's a gas giant, a swirling vortex of hydrogen and helium, the same ingredients that make up our very own Sun. And it's this composition that has always made astronomers wonder, could Jupiter have been a star? Now, I'm not talking about some science fiction scenario where Jupiter suddenly ignites into a second sun. I'm talking about the cosmic what if. You see, Jupiter, for all its might, is a cosmic underachiever. It's like that friend with all the potential in the world who just never quite reached it. Jupiter is massive, don't get me wrong, but it's not massive enough. It needed about 80 times more mass to tip the cosmic scales and achieve stellar ignition. 80 times, that's like saying you need 80 Jupiters to even begin to think about making a star. So we're left with a fascinating thought experiment. In another part of the cosmos with slightly different conditions, perhaps Jupiter-sized objects do become stars. But here in our solar system, Jupiter remains the king of the planets, a testament to the delicate balance of mass and gravity. Jupiter's atmosphere is like an abstract painting on a cosmic scale. It's a swirling canvas of colors, with bands of white, red, brown and yellow, all in constant motion. These bands aren't just for show though. They're actually clouds, but not the fluffy white clouds we're used to here on Earth. These clouds are made up of ammonia, water, ice and other compounds, all whipped into a frenzy by Jupiter's intense winds. Imagine winds so powerful they make Earth's strongest hurricanes look like a gentle breeze. We're talking hundreds of miles per hour, folks, and those colors? They're not just pretty to look at, they're clues, my friends, clues to the chemical cocktail brewing in Jupiter's atmosphere. The reddish hues, for example, are thought to come from compounds called phosphine, while the white bands are likely ammonia ice crystals reflecting sunlight. But here's the thing, despite decades of observation and study, we still don't fully understand the complex chemistry and dynamics that create Jupiter's stunning, ever-changing atmosphere. It's a puzzle that continues to fascinate and challenge planetary scientists. When we think of planetary rings, Saturn immediately springs to mind, right? Those majestic icy rings are practically a celestial icon. But did you know that Jupiter, our massive gas giant, has rings too? They're not as prominent as Saturn's, mind you, but they're there. A subtle reminder that the universe is full of hidden wonders. Jupiter's rings are faint, composed mostly of dust particles rather than ice. This makes them difficult to observe, which is why they weren't discovered until 1979, courtesy of the Voyager 1 spacecraft. Imagine that, a planet as massive and as closely studied as Jupiter, and we only discovered its rings a few decades ago. So where did these rings come from? Well, unlike Saturn's rings, which are thought to be remnants of a shattered moon, Jupiter's rings are believed to be formed from dust kicked up by micrometeoroid impacts on its smaller moons. It's like a cosmic dust bunny constantly being replenished by these tiny collisions. While Jupiter's rings may not be as visually stunning as Saturn's, they provide valuable insights into the dynamics of the Jovian system. They're a subtle but important piece of the puzzle, helping us understand how this massive planet interacts with its surroundings. So, we've journeyed through swirling clouds, navigated past raging storms bigger than our entire planet, and even dodged a few stray moonlets. But what lies at the heart of it all? What's at Jupiter's core? You'd think for a planet we can literally see with our naked eyes across the vastness of space, we'd have it all figured out, right? Well, the universe loves throwing us curveballs, especially when it comes to gas giants. See, Jupiter's core is less of a solid, easily defined thing like we imagine for Earth, and more of a cosmic enigma wrapped in layers of swirling gases and extreme pressure. It's like trying to study the heart of a hurricane while standing on a cloud. Some scientists hypothesize a dense core of rock and metal, heavier elements pulled together during the early chaos of the solar system's formation. Imagine a primordial seed around which the immense gravity of Jupiter gathered its gaseous layers. Here on Earth we marvel at the ethereal beauty of the aurora borealis and aurora australis, the northern and southern lights. These shimmering curtains of light painted across the sky by charged particles from the sun are a spectacle that has captivated humankind for millennia. But as with most things in the universe, if it happens on Earth, it's probably happening bigger and bolder somewhere else. And in the case of auroras, that somewhere else is Jupiter, a planet that takes these celestial light shows to a whole new level. Jupiter's auroras are the most powerful in the solar system, a testament to the planet's immense magnetic field, which is like a cosmic superpower compared to Earth's. This magnetic field traps charged particles from the sun, funneling them towards Jupiter's poles with incredible energy. But here's the catch. While Earth's auroras are predominantly green, painted by oxygen in our atmosphere, Jupiter's auroras blaze in ultraviolet and X-ray light, invisible to our eyes but detectable by our telescopes. Imagine an entire light show happening just beyond our visual spectrum, a secret symphony of energy and magnetism. And Jupiter's auroras have another secret weapon, a source of charged particles beyond the solar wind, Io, Jupiter's volcanic moon. Io is a tortured world constantly stretched and squeezed by Jupiter's immense gravity, a process that generates intense heat within its core. This internal inferno fuels hundreds of active volcanoes on Io's surface, spewing plumes of sulfur and other materials into space, reaching heights that would dwarf Mount Everest. Some of this material, ionized by the harsh radiation environment around Jupiter, gets caught in Jupiter's magnetic field lines, further fueling those spectacular auroral displays. So, Jupiter's auroras are a cosmic collaboration, a dazzling fusion of solar wind and volcanic fury. They're a constant reminder that the universe is a place of breathtaking beauty, even when that beauty lies hidden in wavelengths our eyes cannot perceive. From the swirling chaos of its great red spot to the hidden secrets of its core, Jupiter is more than just a planet. It's a cosmic wonderland, a gas giant that challenges our understanding of planetary formation, a celestial laboratory where physics plays out on a grand scale. We've journeyed through Jupiter's turbulent atmosphere, witnessed storms that could swallow our entire planet, and marveled at auroras that blaze in ultraviolet light. We've glimpsed the possibility of a metallic hydrogen ocean deep within its core, and pondered the mysteries of its many moons. But most importantly, we've been reminded that the universe is full of awe-inspiring wonders waiting to be discovered. So keep looking up, keep asking questions, and never lose your sense of wonder. What blew your mind about Jupiter? Let us know in the comments below, and don't forget to like, share, and subscribe for more explorations of our incredible universe. Until next time, keep exploring. Keep